ಸರ್ ಗುಡ್ ಮಾರ್ನಿಂಗ್ ಸರ್.
ನಮಸ್ತೆ.
ಸರ್ ನಮಸ್ತೆ. ಅದೇ ನೀವು ಕೋ-ಹೋಸ್ಟ್ ಮಾಡೀನಿ ಸರ್.
ಓಕೆ ಓಕೆ, ನಾನು ಶೇರ್ ಮಾಡಬಹುದಲ್ಲ?
ಶೇರ್ ಮಾಡ್ಬೋದು ಸರ್. ಇವಾಗ ಕೋ-ಹೋಸ್ಟ್ ಇರೋದ್ರೆ ಶೇರ್ ಮಾಡ್ಬೋದು.
ಓಕೆ ಓಕೆ ಓಕೆ.
ನಾನು ಅದೇ ಇಲ್ಲೇ ನಾವು ಹತ್ರ ಒಂದು ಇದಿದೆ, ಅದು ಹುಡುಗರಿನ ಬರ್ತಾ ಇದಾರೆ ಸರ್. ಇನ್ನು
ಆಗ್ಲಿ ತೊಂದರೆ ಇಲ್ಲ, ನಿಧಾನಕ್ಕೆ ಬರ್ಲಿ. ನೋ ಪ್ರಾಬ್ಲಮ್. ನಾನು ಸುಮ್ಮನೆ ಒಂದು ಚೆಕ್ ಮಾಡ್ತೀನಿ, ಶೇರ್ ಮಾಡಿ.
ನಾವು ಹುಡುಗರಿನ ಅಲೋ ಮಾಡಿಲ್ಲ ಸ್ಟೂಡೆಂಟ್ಸ್ ನ.
ಹಾ,
ನೀವು ಶೇರ್ ಮಾಡಿ ಸರ್, ಆಪ್ಷನ್ ಬರುತ್ತೆ.
ಓಕೆ. ಬರ್ತಿದೆಯಲ್ಲ?
ಹಾ ಸರ್, ಶೇರ್ ಆಗ್ತಿದೆ. ಆಯ್ತು ಸರ್, ಆಯ್ತು ಆಗ್ತಾ ಇದೆ.
ಫುಲ್ ಸ್ಕ್ರೀನ್ ಮಾಡಿದ್ರೆ?
ಫುಲ್ ಸ್ಕ್ರೀನ್ ಮಾಡಿದ್ರೆ ಕರೆಕ್ಟ್ ಆಗುತ್ತೆ ಸರ್.
ಓಕೆ ಓಕೆ. ನಾನು ಏನ್ ಮಾಡಿದೀನಿ, ಐ ಕುಡ್ ನಾಟ್ ಆರ್ಗನೈಸ್ ಇನ್ ಒಂದ್ ಸ್ಲೈಡ್ ಮಾಡ್ಕೊಂಡು ನಾನು 3-4 ಫೈಲ್ಸ್ ಇದಾವೆ. ಅದನ್ನ ಒಂದಾದ್ಮೇಲೆ ಒಂದು whenever I necessary ಇದನ್ನ ಸ್ಟಾಪ್ ಶೇರ್ ಮಾಡ್ಬಿಟ್ಟು ಐ ವಿಲ್ ಶೇರ್ ಅನದರ್.
ಆಯ್ತು ಸರ್, ಹಂಗೆ ಮಾಡಿ ಸರ್. ಏನ್ ತೊಂದರೆ ಇಲ್ಲ ಸರ್.
ಓಕೆ ಓಕೆ. ಮತ್ತೆ ಬೇರೆ ಎಲ್ಲ ಆರಾಮ?
ಆರಾಮ್ ಸರ್, ಎಲ್ಲಾರು.
ಇವ್ರಂದ್ರು ಯಾರು ಅನಂತರಾಜ್, ಆಮೇಲೆ ಜಾಯ್ನ್ ಆಗ್ತೀನಿ. ಏನೋ
ಮೀಟಿಂಗ್ ಇದೆ, ಮೀಟಿಂಗ್ ಹೋದ್ರು.
ಅಡ್ಡಿಲ್ಲ.
ಈಗ ನಾವು 9 ಗಂಟೆಗೆ ಅಂತೆ ಮುಗಿಸ್ಕೊಂಡು ಬರ್ತೀನಿ ಅಂತಂದ್ರು.
ಓಕೆ ಸರಿ. ಇದು ಕ್ಲೋಸ್ ಮಾಡಿರ್ತೀನಿ.
ಸ್ಟಾಪ್ ಮಾಡಿ ಸರ್, ಸ್ಟಾಪ್ ಮಾಡಿ.
ಆಮೇಲೆ ಇದು ಮಾಡೋಣ.
ಓಕೆ ಸರ್. ಮಕ್ಕಳೆಲ್ಲ ಆರಾಮಿದ್ದಾರೆ ಸರ್?
ಆರಾಮ್. ನಿಮ್ದು ಈಗ ಇವರು ಫಸ್ಟ್ ಇಯರ್ ಸ್ಟೂಡೆಂಟ್ಸ್ ಇವರು?
ಹೌದು ಸರ್, ಫಸ್ಟ್ ಇಯರ್ ಸ್ಟೂಡೆಂಟ್ಸ್.
ಅಂದ್ರೆ ಮತ್ತೆ ಇನ್ನು ಸಿಇಟಿ ಎಲ್ಲ ಯಾರು ಇವರು? ಆಕ್ಚುಲಿ ಸೆಕೆಂಡ್ ಸೆಮ್ ಅಲ್ಲಿ
ಸರ್, ಸೆಕೆಂಡ್ ಸೆಮ್. ಹೋದ್ ಸರಿ ಸಿಇಟಿ ಬರ್ ಜಾಯ್ನ್ ಆಗಿರೋರು. ಫಸ್ಟ್ ಸೆಮ್ ಮುಗಿದು ಫಸ್ಟ್ ಸೆಮ್ ಎಕ್ಸಾಮ್ ಆಯ್ತು ಸರ್ ಅವ್ರಿಗೆ.
ಸರಿ.
ಸೆಕೆಂಡ್ ಸೆಮಿಸ್ಟರ್ ಹಂಗೆ ಪ್ರಮೋಟ್ ಮಾಡ್ತಾ ಇದ್ದಾರೆ ಮೇಲೆ. ಎಲ್ಲ ಆಲ್ಮೋಸ್ಟ್ ಥಿಯರಿ ಎಲ್ಲ ಮುಗಿತು ಸರ್.
ಸರಿ.
ಲಾಸ್ಟ್ ವರ್ಕಿಂಗ್ ಡೇ 25th ಇದೆ ಈ ಮಂತ್.
ಸರಿ ಆಯ್ತು.
ಓಕೆ ಸರ್, ಆಯ್ತು.
ಓಕೆ, ನಾನು ಇಲ್ಲಿ ರೆಡಿ ಇರ್ತೀನಿ.
ರೆಡಿ ಇದೆ ಸರ್. ನಾನು ಸ್ಟೂಡೆಂಟ್ಸ್ ಅಡ್ಮಿಟ್ ಮಾಡಿ ಆಮೇಲೆ ಇನ್ಫಾರ್ಮ್ ಮಾಡ್ತೀನಿ ಸರ್. ಓಕೆ.
Professor, good morning, Professor. Manjana sir, Anantaraj here. 1 second. Sir, mute ಆಗಿದೆಯಾ ನಿಮ್ದು?
ಹಾ ಸರಿ ಸರ್, ನಮಸ್ತೆ ನಮಸ್ತೆ.
ನಮಸ್ತೆ ಸರ್. Glad to meet you, sir. Through
Fine.
online.
ಹಾ
Yes, sir.
Thank you.
Sir, we'll start in another
meeting.
Yes, sir.
Meeting. You are telling something. Meeting.
Yes, sir. ನಾನು ಮಧ್ಯದಲ್ಲಿ ಹೇಳ್ಬಿಟ್ಟು ಬಂದೆ sir.
Okay.
I told to the principal.
Sir.
He said, no. Anywhere guest is there, you need to go. Another, please go. You need to take care of it. Please do go.
Okay, sir.
Almost ಮುಗ್ದಿತ್ತು, ಇನ್ನೊಂದು 10 ನಿಮಿಷ ಇತ್ತು ಅಷ್ಟೇನೆ.
Okay.
But they are able to manage, sir. No problem.
Yes, sir.
Sir, we'll start in another 2-3 minutes, sir.
Yes, sir. Aramse. No problem.
9:59 ಈಗ. No, 10 o'clock.
Okay.
The students will join another 5 minutes, sir.
Yes, sir.
Sir, sharing option ಬಂತಾ ನೋಡ್ಕೊಂಡ್ರಾ?
ಬಂತು ನೋಡಿ, I checked it.
Yes, sir.
Sharing option ಇದೆ.
Yes, sir. Just give me 2 minutes, sir. 2-3 minutes.
Yeah. Please, sir. ನಾನು ಇಲ್ಲಿ meet ಆಗಿರ್ತೀನಿ.
Yes, sir. Sir, with your permission, we would like to start, sir.
Yes, sir. Please go ahead. Yeah.
One second, sir. 1 second.
Yeah, please go ahead, sir.
Yeah.
Good morning, one and all. Myself, Dr. M. Dinamani, Associate Professor, Department of Chemistry, and it's my privilege and pleasure on behalf of Chemistry Department, DSCE, to welcome you to this webinar this morning. First, I would like to extend a warm welcome to Dr. J. Manjanna, Professor and Chairman, Department of Rani Chennamma University, Department of Chemistry, Rani Chennamma University, Belagavi, Karnataka. Sir, we are very much pleased to have you here as today's speaker, and we would be delighted to listen to you, sir. Now, I would like to welcome our beloved principal, Dr. CPS Prakash, who is a constant source of support and inspiration in all our endeavors. I also wish to offer a hearty welcome to our HOD, Dr. K.S. Anantaraju, Chairman, K.S. Anantaraju, HOD, Department of Chemistry, to this event. Lastly, I wish to welcome my fellow colleagues and my dear student participants to this webinar on this morning. Nanomaterials have gained prominence in technological advancement due to their exceptional tunable properties and enhanced performance over their bulk counterparts. These nanomaterials are revolutionizing various industrial applications due to their outstanding and unique characteristics. The engineering applications of nanomaterials in diverse industrial fields include biomedical, food processing, biotechnology, environmental remediation, construction, renewable energy, electronics, and energy storage, so on. In short, nanomaterials are expected to bring breakthrough development in field of leading cutting edge of nanotechnology. In this regard, I feel privileged to introduce today's speaker, Dr. J. Manjanna, Professor and Chairman, Department of Chemistry, Rani Chennamma University. Dr. Jayappa Manjanna obtained his MSc degree in chemistry and PhD chemistry in the year 1995 and PhD degree in the year 2001 in industrial chemistry from Kuvempu University. He worked in BARC Mumbai during his PhD degree and then as K.S. Krishnan Research Associate from 2002 to 2004. He moved to Japan as a postdoctoral researcher from 2004 to 2010 under JSPS and the JST Fellowship at Hokkaido University, Iwate University and University of Tokyo. He joined Kuvempu University in the year 2010 as an assistant professor in the Department of Industrial Chemistry and worked as coordinator for Nanoscience and Technology program, MTech program. He moved to Rani Chennamma University in the year 2013 as an associate professor of chemistry. His research interests include materials chemistry aspects, including nanomaterials for energy devices, environmental remediation, and biomedical applications. He has published over 85 international journal papers and 3 patents. Presently, his citations are about 2,160 and H index is around 26. He has received research funding from various funding agencies like BRNS, DAE, DST, and VGST, Government of Karnataka, and so on. He has good collaboration with the national and international institutes that has flourished his research. Sir, we are fortunate to have you here, and let us have the pleasure of listening to you on the topic resources, recycling, and applications of nanomaterials for waste management. Thank you, sir. And over to you, sir.
Thank you, madam, for your nice introduction. I think I shall start now with my lecture.
1 second, sir. Stop the sharing now. We'll stop sharing.
Yes, sir. Yes, sir.
Yes, sir. Please go on, sir. Please go on now.
Yeah. Let me start this. Yeah. Sir, is it visible now?
Yes, sir. It's clear. It's very clear.
Okay. Yes, sir. So at the outset, I would like to thank Professor Anantaraju and Dr. CPS Prakash, the principal of Dayanand Sagar Engineering College, Bangalore, for inviting me to give this particular talk to our first year engineering students. So I'm very happy to interact with our young students in the engineering college in Bangalore. Well, I had visited your college almost, I think, 2 years before, where Dr. Anantaraju invited me to give some the invited talk in some international conference. So it has a very good ambience and a lot of good infrastructure and all. I think you are all you should be very fortunate to study in such a very prestigious college in Bangalore. I hope you are enjoying your stay in this Dayanand Sagar Engineering College. So, today the topic I would like to discuss is about the resource recycling and applications. I think I can stop this video part 1 second. Yeah, this should be fine now. Yeah. Well, so this is about the resources recycling and application of nanomaterials for waste management. So in this actually this kind of this particular topic, I will be focusing mostly on this resource recycling, and I will touch upon little because you must have heard these nanomaterials. I mean, many lectures. I just guessed like that. So if that is the case, I will not dwell much into these nanomaterials and all. So nevertheless, I will touch upon after this resource recycling and all. So see, this resources recycling again, it is basically talking about some e-waste treatment. So this is a common word, we talk about this e-waste. So this often you keep reading about this e-waste and what are the repercussions of this, generating a lot of e-waste, all those things. Well, here, so among this e-waste, I will be focusing only one typical case, so that is about some lithium-ion battery. Okay, and the technology being developed to recycle certain useful materials. Okay, here resources recycling is to recover some valuable metals and other components from the e-waste. So that is the main purpose of resources recycling. And you have a lot of advantage. You can keep on talking many things about how advantageous it is and how you can save, you can develop technology towards the sustainable development and environmental friendly approach and the science and technology towards the overall development. So all those things. So if you look at this resources recycling, basically, it encompasses all these things like a backend technology, developing a backend technology for e-waste. What is that backend technology? Is the end of life management after the usage. So what you call the spent e-waste. So e-waste includes, I'm going to talk more on this lithium-ion battery, but nevertheless, it includes all sorts of electronic components. Everywhere, the same technology or the process can be extended to many other e-waste treatment. Okay, so this end of life management, once all these electronic components, electrical and electronic components that after usage, see, we never bother about how it is being processed, treated. So it has a lot of, it is very useful. One can recover very valuable materials from such components. For instance, if you know the spent, say, computer and all, see the kind of if you see the electronic circuit, the printed circuit boards, and the various materials involved in that, including rare earth materials. Okay, therefore, it is high time we should think about in this direction. Even if, in fact, all these developed countries now banking on this kind of a end of life management issues. So it may be from science and technology viewpoint, and also sociological, environmental. Okay, so all these issues are now coming to forefront. So we should be aware of. In addition to developing technology on one side, but also the impact and the I would say end of life management of all those devices has to be considered. Well, so now there is even in the social science, including say they talk something called circular economy. So how you can bring in this circular economy in the sense by recovering those elements or the components. Okay, at first one should use the components to the maximum extent, all the devices, and once it is when it comes to the disposal, then you can think of the scientific way of management, dismantling, recovering, all those things. And there is something called very exciting word called urban mining. So this is also something very this thing like how instead of to get this certain say rare earth materials. So going for in a conventional mining, it would involve thousands of tons to recover a few grams of very valuable materials like rare earth minerals. Okay. On the other hand, see the lot of e-waste being generated, so that can be treated as your raw material for such a mining, and it involves very highly concentrated metals are available. Only thing is you need to develop a technology and process. Okay, that's what see. I just okay, yeah. So this kind of when you come to the technology process development, it involves both science and engineering. It is not just engineering or science. It has to be